So next we are going to see pulse measurement. Okay. So what is pulse? I think pulse will be seen by the doctor in the wrist of the hand. Okay. So the in the through the wrist of the hand, they will be checking the pulse of heart. Okay, heart pulse only will be checked through the wrist of the hand. Okay. So that pulse, how it's created? Pulse is nothing but the pressure which is developed in the heart muscles. Okay, while your heart muscles contracting and um, expanding. Okay, contraction and expansion will create the pressure in the heart that will produce the pulse. Okay. So, when heart muscle contracts, blood is ejected from the ventricle and a pulse of pressure is transmitted through the circulatory system. So, heart muscle, while your heart muscle contracting, the blood will be moved from ventricle part of the heart so that a pulse will be created. That is nothing but pressure will be created, which will be transmitted throughout the circulatory system. So, that will be heard as a pulse, okay, in the heart. This pulse can be measured at various point. We can measure the pulse at various point. So we can sense the pulse by placing our fingertip over the radial artery in the wrist. So in the wrist, you can check the pulse by sensing the um, radial artery. Okay, the artery which is running from the heart to the hand. Okay, so in that artery vessel, blood vessel, you can check the pulse of heart. Okay, this pulse travels at the speed of 5 to 15 meter per second. For per second it will be running 5 to 15 meter. Then photoelectric method will be used for measuring the pulse. So what is photoelectric method? Light energy which will be converting into electrical signal. So here the pulse measurement has two types. One is transmittance method and another one is reflectance method. So this is transmittance method. You can measure the pulse by using the finger. I think you all know. While you are going to hospital, everyone will check the pulse through the finger. Okay. So the finger you will be holding that device. Okay. Your device will be holded in your finger for checking the pulse. There in that device they will be using photodiode. Okay, photodiode will sense the biosignal from your finger. Okay, that the movement of pulse will be checked by using the photodiode. Okay, that will be showing the signal to the doctor. Okay, so that photodiode will convert the biosignal into electrical signal and then it will be displayed in the device. So transmittance method, first we are going to see transmittance method. So இதில் தான் photodiode and LED will play a role. Okay, so photodiode as well as LED you can use for transmitting the signal, that is biosignal into electrical signal in the finger. So LED and photoresistor are used in this method. These are mounted in a enclosure that fits over the tip of the finger. Light is produced by the LED. So light emitting diode will produce light. The same light is passed through the finger. So for each heart pulse, the blood is forced to the extremities and the amount of blood in the finger is increased. So while you are passing the LED light through the finger, what happened to your blood? Blood will be forced to move. Okay, to a maximum level. Okay, so the forcing blood in the finger will be increasing while you are applying the LED light in the finger. Okay, so optical density will be changed. Okay, so due to the pressure in the blood, the optical density will be changed. So the light transmitted through the finger is decreased. So after that, after increasing the optical density, the light automatically will be goes on, the intensity of the light will be decreasing. Okay, which light? LED light. So this light is received by the photoresistor. So here LED going to act as a transmitter, and receiver will be photoresistor. So the transmitted light to the finger will be collected later on by the your photoresistor. Okay, this photoresistor will be connected with the part of voltage divider circuit. I think you all know what is voltage divider circuit. In electronic circuit 1 you will be learn. So nothing but the resistors which will be dividing into 2 will be connected as the additional circuit to the photoresistor for producing the voltage value, different voltage value. Okay, so the voltage produced by this circuit is directly proportional to the amount of blood flow in the figure. So the voltage which is produced in the photoresistor, because the work of photoresistor is nothing but collecting the light from the finger and converting them into corresponding electrical signal. Electrical signal means nothing but voltage into current. Okay, so the voltage value which is converted in the photoresistor will be directly proportional to the amount of blood in the finger. This is not figure, finger. Okay, this is finger. The output will be recorded by using any short recorder. Okay, strip short recorder. The next, reflectance method. So in the reflectance method also you will be using the same LED and photoresistor, but here you will be applying the reflectance concept. That is, in reflectance method, LED is placed adjacent to the photoresistor. So near, they are going to place the LED and photoresistor. LED will emit the light in the hand or finger. Okay, this light will be reflected from the skin and the tissue falls on the photoresistor. Okay, that is nothing but the light which is emitted from the LED will be reflected from the, okay, reflected from the skin and tissue, reflected from the skin and tissue will fall on the falls on the photoresistor. Okay, the emitted light from the skin and tissue will be falling on the photoresistor which is placed nearer to the LED. Okay, so this reflected light will be varying depending upon the blood flow in the finger. So based on the blood flow in the finger, the blood flow in the finger will not be same for all the time. It will be varying for time period. Okay, so time to time it will change. So for that time period you will be getting the different blood flow with respect to light passing through the LED. Okay, so that reflected light will give the voltage value based on the blood flow in the finger. So the photoresistor is connected as a part of the voltage divider circuit as usual. In already said in the previous method, transmittance method, voltage divider circuit will be a additional circuit for the photoresistor to provide the different voltage value. Okay, so that the output which is obtained will be directly proportional to the amount of blood flow in the figure. So the output can be recorded using the slip shot recorder. The same topic. Okay, both methods are same. Only difference is that you will be getting the light, direct light from the finger will be connected in the photoresistor. But here you will be getting the reflected light from the skin and tissue. Okay, that's the difference. Other than that, it will be same to each other. The next method, calorimeter. So other than reflectance and transmittance method, you will be having one more method, that is calorimeter. Oh, sorry. Calorimeter is the next topic. calorimeter. So any doubt in pulse measurement? So pulse measurement la rendu type da. Calorimeter is not a type. That is another topic. Okay, only two method, reflectance and transmittance method, because I said only two method. Okay, so pulse measurement has only two methods, transmittance and reflectance. So in this two method, any doubt? If you have doubt, clarify now itself. I think there is no doubt. Shall we move on to next topic? Calorimeter. What is calorimeter? What is calorimeter? For what purpose you will be using calorimeter in the chemistry? So calorimeter is nothing but it is a meter which will be measuring the concentration of the chemicals. Okay, substance. Okay, that will be called as calorimeter. Okay, which will be measuring the concentration level of the substance. Okay, so blood serum is a complex fluid that contains numerous substance in solution. So blood serum ங்கிறது ஏதோ ஒரு new word. Don't think that that is a new word. Simply we call the blood serum as blood. Okay, so blood is nothing but it contains many complex fluid, that is you'll be having WBC, RBC, platelets. Okay, so many cells are present in your blood. Okay, so that will be equal to your numerous substance in your solution. Okay, so blood serum is a complex fluid which will be equivalent to your numerous substance present in the solution. So the determination of the concentration of these substance is performed by specialized chemical technique. So if you want to determine the substance present in the blood, okay, concentration of the substance present in the blood, you have to use some chemical techniques, that is calorimeter. Oh, calorimeter will be used for testing the substance concentration of the substance present in the blood. Okay, so this principle makes use of the fact that many chemical compounds in solution appear colored with the saturation of the color depending on the concentration of the compound. Okay, so here we are going to find the concentration of the blood components, that is substance, can be found out using the color. Okay, in the saturation. Okay, in the saturation time the color changing, okay, with respect to the concentration of the particular compound. So based on that, you will be finding the concentration of substance present in the blood. Okay, so the calorimeter, so other name for calorimeter is filter photometer. Okay, is an optical electronic device that will be measuring the color concentration of a substance in a solution. So color concentration of the substance present in the blood will be tested by using calorimeter or filter photometer. So இங்க வந்து சொல்யூஷன் யூஸ் பண்ணிருக்காங்கன்னா that is nothing but blood. Okay, so this light absorption can be used to determine the concentration of the substance. So here we can use the absorption technique. Okay, so if you pass the light to the blood, then the absorption of the light in the blood can be used for determining the concentration of the substance present in the blood. Okay, so now you assume that your solution, that is blood concentration, is C, which is placed in a cuvette. Okay, you are taking a blood or solution in the cuvette with a length of light path L. Okay, concentration will value C. அதே மாதிரி light, length of the light path L, Okay, so light of an appropriate color or wavelength is obtained from a lamp through filter F. So the color of the light, that is light color as well as wavelength, can be determined as F. Okay, we can name it as F. So we will obtain the light from the lamp through the filter only. Okay, so the light that enters the cuvette. So in the cuvette only you are going to have a solution or blood. So in that you are going to pass the light which is transmitted from the lamp through the filter. Yeah. Okay. That is going to be entered into the cuvette with a certain intensity, that is 10. Okay. The intensity of the light is 10. So, with the part of the light being absorbed in the solution, the light leaving the cuvette has a lower intensity 1. This is 1. Sorry, I1. Okay, this is I0. This is I1. This is I0. This is I1. Okay, so in the cuvette you are going to have a blood or solution. So you are going to pass the light from the lamp to the cuvette which is having a solution. So while you are passing the light entrance, at the entrance of cuvette you will be having the light intensity as I naught. Okay, I0 or I naught. While leaving the cuvette, you'll be having the intensity as I1. Okay, while entering, you will be having higher intensity, but while leaving the cuvette, you will be having the lower intensity I1. Okay, so you can express the relation of transmittance of the light to the solution will be represented as T equal to I1 by I naught into 100. Okay, so T stands for transmittance. Transmittance. So I1 by I naught. I1 is leaving cuvette. Okay, in light intensity while leaving the cuvette. I naught is light intensity while entering the cuvette. Okay, so I1, the ratio between these two intensity will give the transmittance T of the solution in the cuvette. Okay, in percentage. See, that is represented in the diagram. So you are going to pass the light from the lamp. Okay, this is going to be passed through the filter. This is filter. Yep. Okay, so before that you'll be your light intensity will be large or high. This is cuvette which will be holding the blood or solution. So while entering the cuvette, you will be having I naught intensity. The light will have I naught intensity. While leaving the cuvette, you will be having I1. See, if you have any other cuvette solution, second solution, if you place here, then intensity the which you leaving from the first cuvette will be entered into the second cuvette. Okay. So while leaving the second cuvette, you will be having decreased intensity than the before intensity I1. Okay, I2 avida, sorry, I1 avida I2 will be very less. Okay, so while passing through the liquid the intensity goes on decreasing. Which intensity? Light intensity. Okay, goes on decreasing while moving in the solution or blood. Okay, this is the concept. See here, here your cuvette is wide. Okay, the length of the cuvette is double arc 2L. Okay, so that you will be getting the I2 intensity, because here 1L another cuvette la move ஆகிறப்ப தான் I2 you are getting the same thing. The length of the cuvette increased, that is doubled, means you will be getting this intensity only while you are leaving this wide cuvette. Okay, not I1, I2 will be getting. So I1 I2 don't confuse it. Here இது 10 னா இது 5, இது 2 னு வச்சுக்கோ. ஓகே, அப்போ இங்கே 10 என்ட்ரு ஆகிறப்ப யூ வில் பி கெட்டிங் 2 நாட் 5.